All right, welcome everybody. Welcome to DevOps, our conference about DevOps and all technologies around us. And today I am pleased, I'm pleased to announce Kerim Satirli from HashiCorp. Kerim, hi.
Привет. Thank you for having me.
Oh, привет. You can speak Russian. So if you want to speak Russian, we have some speakers who translate, like they transitioned from speaking English to speaking in Russian. And after that, after a couple of years, they even were managed to snatch the Russian citizenship. So there's
That is definitely a goal for the future. I haven't spoken Russian in 5 years, so I don't want to upset everyone by mispronouncing words, because I know I will. And our conversation would be very topical. I could ask you, как дела? And then you could respond. And then we could probably get some other things like food, which would be great.
Yeah, we get some пирожки, пельмени, whatever, and obviously we can drink vodka. Where are you coming to us today?
So I'm
Where
coming
are you
today
located?
to you from Amsterdam, my home office, which has been my office for the past 1.5 years, like everyone. Eventually, I know we'll have shared offices again, which I'm very excited about. But for now, having the freedom to set up your space the way you want it, beautiful.
Yeah, that's great. And Amsterdam is also definitely a very desired travel destination for many Russians, just like speaking from experience. And hopefully soon we will be able to travel again and do all these nice activities like seasighting and bike riding in Amsterdam is very popular. So
See, for me, I'm more excited about spending a winter in St. Petersburg.
nice.
That was just a better memory than a winter in Amsterdam.
Oh, yes. Hopefully next year. So what do you think? Shall we start? Shall we go to the talk?
Let's get right to it. Let's talk about infrastructure.
Let's do it.
Let me share my screen. Just want to make sure you can see my screen and my slides. And that's perfect. So let me switch off this thing and let's go. So what I want to do today is I want to start off by taking you back to 2018. 2018, a project I worked on. It was an IoT project. So basically a mix between sensors deployed in hard to reach places, as is the case, and software and infrastructure in the cloud that you may or may not have direct network connectivity with. Because, who doesn't like problems? The team was part of a government-like entity, so we had lots of red tape. Many decisions were made mostly by committee rather than by engineers and architects, and we had very little wiggle room. And the deadlines, they were, shall we say, more of a suggestion than a strict requirement. This was great. Relaxed deadlines means more time to optimize your code, and let's be honest, many engineers love the time to optimize their code, right? I mean, I know, I do. So I was part of the operations team. We started building our infrastructure, and when I started, things were a little bit strange. We're talking 2018, 3 years back, but yet we started out with vendor-specific instructions. We're not talking CloudFormation or ARM templates. We're talking runbooks, printed runbooks. So let's say it's Monday, a new sprint kicks off, and you need to deploy something like a highly available SQL server. Kruta, here's a PDF, follow these steps, make sure to check the next 23 pages, on which button to click. Definitely turn the page over because we saved some printing, so it was actually 46 pages, and at the end, hopefully it all worked out. Whew. Now, of course, we codified those runbooks. We made sure we had at least some of the 12-factor principles covered. It took us half a year to convince people that the 12-factor principles are actually worth having. But we got some more automation in place. But that's not what this story is about. This story is about the email that came next. Monday, sprint had ended. We've been doing pretty good work. We've codified some stuff, and you get this little ping that says, new email, and you know it's from your boss, and you look at it and it's like, Slushit, can we deploy this to production? We've got an exposition coming up, and we want to show what you and the team have been working on. Well, of course we can deploy this. What kind of question is that even? So let's talk about trust. In a social concept, and this is where it gets interesting. In a social concept, oops, sorry, that was the wrong button. In a social concept, the idea of trust is generally recognized as 4 types. Closest to you is, of course, the trust in yourself, and in our case, in our own engineering skill. Very few engineers look at their code and go like, man, I'm a horrible engineer. A little bit further out, you have what is referred to as a trust in neighbors. In social science, this would refer to the people you live with, the people in your building. In our case, we're talking the trust in direct teammates and colleagues. And yet another step away is the in-group. So this refers to associated teams and the rest of the engineering organization. Also product, and depending on your company, design and others, testers, things like that. Finally, we've got the out-group. Think of this as external contributors. It might be vendors, it might be contractors that you don't have a direct one-on-one connection with. And then for the past 15 years, you've always had to put some trust in the general public, because most software projects use at least some form of open source, right? And to be able to use open source, you'll need to rely on the competence of strangers. That's basically social trust. So let's start by talking about trusting yourself. In this section, we'll talk about some of the things you can do to make sure your code is trustworthy. First of all, and this is an interesting one. First of all, when you deploy code, you need to have code. Makes sense, right? Like this compute instance we have here. And note the resource settings. We're using 2 units for cores and 4 gigabytes for memory. This is easily committed, right? Very basic example. Code gets written by people, and people sometimes make strange choices, like changing the core units from 2 to 20 and the memory to 48 gigs. That kind of thing gets costly quickly. And those changes affect what you deploy and how you deploy it. So in order to trust, we must know who changed a specific line of code. And to do that, let's start at the very basic level, signing your Git commits. We learned this same exact lesson with DNS records for mail servers. We learned it for a lot of things. With Git 2, we can use keys and public and private key signing infrastructure to make sure we can trust the sender or the commit author, in this case, that they are who they say they are. Signed commits are good commits, because signed commits mean you know who committed it. And you can trust that information. And in today's world, this is useful. It gets you one step further away from a supply chain attack. And that's a good thing, because depending on the size of your company, at one point you will be part of that supply chain and you might be phished. There might be something that interrupts you. Not trying to spread fear here, trying to help you make your code more trustworthy. You want to decrease your attack surface at any point. If you're using GitHub, there's good options for that. GitLab has the same. If you're basically adding 2-factor authentication, private SSH keys with passwords, you're making it a lot harder to impersonate you. And as a bonus, if you're using GitHub or GitLab, your commits will show up as verified in the web interface. My colleagues told me to point this out specifically because we're all suckers for badges, and anytime it says verified, that's a good thing. So now that we have a way to ensure that our code is attributed to us, let's make sure to actually write good code. Of course, the definition of good code or great code is highly, highly subjective. At a base level, we can discuss tabs, spaces, which editor to use, and how many spaces even. But let's skip right past that. First up, we're going to be talking mostly about Terraform. So we'll talk about code formatting and all the other options with relation to Terraform. In Terraform, just like in Go, you have a command called fmt. Very simple. And when you run it, you'll see that your code gets properly indented or correctly indented. And just a side note, we define correct here as a way it was decided by the Terraform engineering team. Like Go, Terraform defines this globally, and you don't have to worry about it, but you also don't get to change it. Bonus, you have no say in it, so you also don't need to learn it, and there's no rules because once you run it, it works. If you're using a different tool for infrastructure as code that's not Terraform, you will have similar tools. So this is definitely something to think about. Predefined formatting options are great, but if you can't predefine them from your tool stack, have your team decide on them. Agree to a single style with your team and make sure everyone sticks to it. No matter if it's an automated commit through something like Dependabot or something done manually, something done from a mobile device, make sure it runs all the time and just don't debate the white space. And while you're at it, add it to your automated test suite. So every new pull request and merge request gets treated the same way. Next up, I want to talk about syntax validation. Built in Terraform is this option called validate. And because it's built in, it is a really great option to start with. It basically ensures that misspellings of attributes and incorrect references get caught before you even attempt to deploy them. Terraform Validate is great, but there are a few caveats. First, it runs locally, exclusively. This is great when you're on a plane and want to verify your code. Not so great when you're actually working from somewhere where you have an internet connection and just want to know if your code actually works. It doesn't pull a remote API, so your validation might say everything is okay, but the remote API might disagree because you have a value in there that's not actually existing. You might be setting an availability zone that validates as a string, which is what Terraform looks for, but the zone doesn't actually exist or your account doesn't have access to it. Second, like format, this option is not an operation that runs automatically. If you're using Git, then I can recommend the Terraform pre-commit hooks. And if you're using GitHub, HashiCorp also maintains a set of GitHub actions you can use to lint every request. These are cheap operations in the sense that they only take a few seconds to spin up, so they won't eat into your action minutes. It's a 5-minute operation to add them to a repository. They're worth it. But let's go a little deeper with static code analysis. For Terraform, there's a community-maintained tool called tflint. There are other tools out there like tfsec, and while I can make a choice for your engineering team, I can highly recommend tflint. It does good things. With it, you get recommendations on how to make your code even more consistent. Like Terraform format, it has a great number of built-in rules, but you can extend them if you need to. And if you're on one of the major cloud vendors, like AWS, GCP, or Azure, you even get additional validation, helping you figure out if you use a wrong instance type before you even run Terraform apply. Now, all of this is very good because it's cheap, operationally speaking, it's free software, and it makes your code better. But we're not yet at great code. We're just slowly getting closer. So next thing I want to talk about is pinning versions. You have two options here. On one side, you can pin to a specific Terraform version or version constraint. Personally, I'm a huge fan of pinning to a specific version because let's say I run this code with Terraform 1.0.10. I know that this will continue working with 1.0.10. If you clone this repository 6 months from now and Terraform 1.2 might be out at that point, the required version check would fail if you don't have access to this version. So at the very least, you'll know that this was not designed with the current version in mind. And that's a good thing. Because when code breaks early, you don't make mistakes, or you make less mistakes. Let me put it that way. On the other side, you can also pin specific provider versions. You might be wondering, so which one should I do? Do both. I'm serious. The Terraform team made a promise to make all 1.x versions mostly compatible with each other. HashiCorp has promised to make great efforts to make sure Terraform 1.9 can interact with 1.0 code. Of course, if your required version has a constraint for one of the versions, that's a different story. But in general, unconstrained code should continue working. And so really the question is, can you trust the Terraform engineering team? I'd argue yes, but I also work at the company, and these are people I know, but you might not know them. So that brings a question. How can you trust people you don't know? We'll talk about that a little bit later. For now, limit your exposure and constrain your code to the Terraform version and the Terraform provider version you're currently using and currently testing with. This way, just like with verified commits, your attack surface gets severely limited. And as a bonus, upstream changes won't affect you as much. Many of the Terraform providers, of the first-party Terraform providers, get a new release every week. If your PR has an average lifespan of 5 days before it gets reviewed and merged, you might actually be breaking into a new week with a new version. Now, depending on the industry you're in, and depending on the guidelines for your infrastructure, having automatically updated versioning might actually invalidate your infrastructure, might invalidate your pull request. So if you're automatically updating to the new version, let's say in our case, we're going from 0660 to 0661, then technically the whole review is invalid because you're using a new version. Starting from scratch again is never fun, so pin your versions. Build trust by being very specific in what you add to your code base and what versions you use. Terraform makes this easy through two things. On one side, you've got the required providers and the required versions. On the other side, you've got the Terraform log file, terraform.log.hcl. Anything you add in the Terraform stanza that we just saw, and then run Terraform init, will get captured here. And this file is like any other log file. It contains the hashes that can help in determining if the version you tested against doesn't just match in name, but also in checksum. That's a good thing. If you're automatically updating to the new version in your code, like we just said, that means you have no guarantee that your PR works the way you intended it to. Now imagine you're using version 0660 of the Yandex cloud provider. The provider was found to have a bug, and the release was pulled. But you're super quick, right? You're updating your infrastructure. You had already downloaded the binaries onto your build machine. And an attacker somehow managed to gain access to the relevant GitHub repositories and pushed a new release with new tainted binaries. Without a log file, a future deployment will not know that the checksum has changed because it has no record of it. And you can't compare against that which you don't have. So if you're wondering, should I commit this file? Definitely commit this file. It makes your version pinning even stronger. Now, so far, we're 3 parts in, right? Formatting some code, linting it, validating it, and version pinning. If you have to leave right now because it's dinner time and you do nothing else but these 3 things, you've already made a huge difference in making your infrastructure more trustable. If you're still here, I'd love to talk to you about some more advanced use cases. So let's switch away from CLI options a bit and have a look at some architectural choices. Terraform has a concept of inputs and outputs. And we're going to talk about the joke of garbage in, garbage out in a little bit, but for now, let's talk about variables. Variables are inputs, and outputs, well, they're outputs. This is the advanced track, so I don't have to explain too much of that, but it's important to note, to consider both of them as part of a contract. And we'll get into that a little bit later. Variables are one of the best features of Terraform. They do exactly what you think they do. There's no surprise here. But there may be some things you aren't fully using, so let's have a look. First of all, variables support two types of validation. The easiest one to write out is type. With this, you can define a string, a map, an object, a Boolean. You can also define complex objects with child keys, where you can define each child's type. So let's say you want to define a storage bucket. You could define the name as being a string and some flags as being Booleans, while defining the tags as a map. This is really useful if you have objects where you can reliably predict what they're going to look like. Next up, and this is a more recent version, next up is sensitive. Setting a variable as sensitive prevents Terraform from showing its value in a plan or apply output, or when you use the Terraform output command, and even when you use that variable elsewhere in your configuration. Terraform has some knowledge of which variables should be secret or sensitive by default, but because we can't reliably predict every part of your infrastructure, you have an option to just mark something as sensitive. Maybe you're setting up the Stripe provider for payment processing, and you need to have a form of key in there, an identifier that you don't want to be leaked. Setting it as sensitive makes it very hard to get this out. And it also ensures that you can't accidentally print it to screen. We often have these situations where we want to demo something to a colleague, to maybe a live stream. At that point, having sensitive set to true is useful. Finally, the second type of validation is possibly my personal favorite. Validation blocks inside Terraform variables are a great feature to build custom validation for your own variables. So that means that a variable that contains something like an environment prefix, let's say test, dev, prod, can actually validate it against. Where this gets interesting is that dynamically defined values that are incorrect, so something you override, will be caught before Terraform even tries to build an execution plan with them. So before you can successfully complete Terraform validate, you will have to have the validation pass. And literal comparison isn't the only thing you can do. You can do calculations on subnets. I know I definitely need that stuff validated for me because CIDR ranges are hard. Or you could check the length of a string. There are many options. You basically have access to all the common Terraform functions, and you can check if the validation makes sense. And just like with version pinning before, the same rule applies. Make your validation as restrictive as possible to prevent surprises. No surprises means more predictability. That means being able to trust more. And because you're the one who's building this code, because you're the one who's building this infrastructure, you'll also know which values to validate against. And if you don't, that's okay. I try a new cloud ever so often. You bring the concepts that you know, but you might not know specific rules. Like a folder or resource group needs to have at least 4 characters, but may not be more than 24 characters. It needs to have a specific combination of characters. Once you discover those things, help yourself, help your team, add those values inside a validation block. When you do that, it turns a you problem into a team problem, because everyone can now look at the code and understand, hey, my code is failing or not validating properly because I'm not hitting this constraint. And when you involve your team, you're spreading knowledge. You're creating buy-in, you're creating equity. And if you figure it out collectively, what good values look like, and then update the error message that you can see on the screen to give a meaningful suggestion, you're making your code nicer to maintain in the long run. And those little bits of documentation are super, super helpful. You know, like how many organizations have unspoken rules. We're trying to get away with that by having culture guides, culture books, something that explains like, hey, this is how we operate. That's very cool, but there's still stuff that's only in people's heads. Like, oh, don't do this kind of deployment on a Tuesday because we know that the validation has to go through a third party and we can't validate it this way. Got it. That's hard to work around. But knowing that you can only deploy to zone 1A and 1C, that's easy. All it takes is a single line of code. And while you're at it, consider adding even more, much more documentation to your code base. This one always makes me smile because the whole idea behind infrastructure as code is that you basically have executable documentation, right? If you look at HCL, the language Terraform is described in, it's pretty human readable. It's also machine readable. So this is great, but it does mean that your documentation should stop there. Of course, people sometimes say, but I could easily look this up. I can find this on the internet when I need to. For me, why not save yourself the trouble? Make it easy for me to maintain the code. Context switching is expensive. Storage is not. So add an extra line and turn the code that you currently see into something like this. You'll note references to the resources and data sources. For me personally, I make it a habit to link to documentation for every resource. I know a lot of my colleagues do as well, hopefully in part by inspiring them to do that. And I like to think of my code in a way that I'm maintaining this now, today, right? But I really don't hope to be maintaining this for the rest of my life. I also might be doing something entirely different tomorrow. I might not be working on compute instances. I might be working on messaging queues. I don't have the capacity to remember everything, but I have the capacity to copy and paste a link to the right resource. Some resources are much more involved. Anytime you talk about security, there's usually a lot of stuff that goes unsaid. Add it to your code base. Describe those tricky parts and make it easy for people to follow along. You don't need my permission for that, but if you do, I'm here to tell you, you have my permission to add more comments in your code than actual code. GitHub doesn't show you the distribution between comments and code. It just shows you how much code you have in a specific language. But I'm pretty sure if it did, the stats for my repositories would usually say about 2/3 are comments and 1/3 is actual code. I like my stuff to be predictable. I like code that's boring. If stuff breaks, I want to have a single look at it and be able to determine this is broken because I used the zone 1D, which doesn't currently exist. And this is where validation also helps. If you know a resource has constraints, like we talked about, the 4-character minimum, 24 or 28-character maximum, validation really helps. And it becomes part of your documentation. So we talked about this before. Garbage in, garbage out, right? So let's prevent that and talk about your code outputs a little bit. First of all, Terraform outputs are a great way of getting stuff out of your Terraform code. If you don't use modules, Terraform outputs will print to your screen and can be consumed through additional tools like Ansible and other things. But it's even more important for modules because you can do some pretty good stuff with it. Think of generating URLs for applications and other things. If you believe in trust but verify, you could, for example, mold an output that has the URL to the console of your cloud provider, and then filled in, if you know what the pattern looks like, the resource ID that you just created. Makes it very easy for a module to just run through, and at the end you have a clickable URL that you can go to and check, hey, does this look good? Not always needed, but certainly helpful. And while you're building outputs, make sure you add a description to it. Documentation is important, and every so often you'll find that not adding a description right now will eventually cost you down the road. There's two hard problems in IT, as the joke goes: caching, naming things, and off by one errors. And naming things is hard. So while my output right now, console compute instances overview, makes total sense to me, half a year down the road, I will have no idea that that actually refers to a URL value. But because I have a description in there, I can look at it and see, hey, this is what it is. Similarly, for something like the folder ID, which I see I have a typo in, I can set something like sensitive equals true to make sure I don't actually print my folder ID, but do bubble it up. And as you're building your inputs and your outputs, you're thinking about your infrastructure, hopefully. Hopefully you're also thinking about your infrastructure when you're version pinning and keeping everything in mind. And that's a lot. I get that. There is an insane amount of work that goes into building proper infrastructure. And we're talking proper, not perfect. But as you're building, you'll hopefully detect some patterns. And those patterns are basically the building blocks of your platform, of your application. And those are flows you should modularize. So let's have a look at a very simple module. In our case, we'll have a look at a website host. I'm using a severely stripped down version here just to convey the idea. So I'm using Terraform plan to print the output, and even that isn't a full module. At a quick glance, you'll see that we're creating four different resources. We have 2 compute disks, one for the operating system, one for the data. We have a compute instance itself, also useful, and a DNS zone. And if we look at this in a dependency graph, this gets actually a little bit more interesting. We can see a little bit of what's going on here. I'm using a tool called Rover here that a colleague of mine built, and it basically visualizes your Terraform resources even before you apply them, and helps you better understand how they're connected. And you'll note that there's a few hidden references. We have a handful of variables. We have some outputs, 2 data sources for network and a subnet. We have the compute disk, of course, that we talked about, and this is just the internal one. And of course, the compute instance itself. Oh, and finally, we have the DNS zone. This is a lot. And I haven't even included all the additional networking settings, firewalls, load balancing, IAM service accounts. That's a lot of resources. Possibly a lot of data sources as well. And while they might make sense together right now, this is far from minimal. So start by finding the minimally viable pattern and turn that into a module. When I initially spoke with Victor about this presentation, I pitched the idea of basically defense in depth, having separate gates that you need to go through before your stuff breaks. And this is really what it comes down to. We're trying to limit the blast radius here. We're trying to make sure that a small change on the left side doesn't affect the right side too much. So in our case, we'll first want to codify some of the base resources. I'm calling this an IAM module, but we could also have a meta module that goes even one level further. Here, I'm codifying a resource manager folder, IAM service accounts, service keys, possibly, hopefully, some policies and policy bindings. And we'll also want to have outputs that help us further down the road. So we'll export the zone ID, the folder ID, and of course the service account references. Next to the IAM module, we'll work on a networking module. Most of our networking stuff does not change all the time. I don't like changing code that doesn't need changing. So we can codify our VPC network, the subnets, the security groups. We're not going to define security group rules here unless we know those rules apply to most consumers of the module, but we'll at least have the security group in there because that makes it a lot better for maintenance. And you'll note that one of the data sources or one of the inputs we use for the networking module is actually consuming the output of the IAM module. This composability is useful because it removes stickiness from your code and makes it less fragile. Rather than have a single module that does it all and therefore can break it all, you have smaller modules that just pull information from each other. Less fragile to me means more trustworthy because you can rely on your tooling rather than human oversight. Because humans are fallible, and that's okay. We're not machines, we make mistakes. But acknowledging that and making sure you don't make as many mistakes, that's where you grow as an engineer, also as a human. So start by finding the minimally viable pattern that works for you and turn that into a module. Give each module their own code repository. We talked about this before. Context switching is expensive, storage is not. Add a new GitHub repository or Git repository. Don't just make it a folder, make it standalone. And limit the blast radius of changes. A small code base is a code base that changes very easily, right? It's good, limits blast radius. So separate your architecture into logical units. We started with the IAM module. So I'd say ask yourself, does everyone in your engineering team need access to IAM? Maybe you're a very small company and everyone has access to everything. That's cool. But maybe they don't need to have access to it. So make it a separate repository. That means you can now use role-based authentication and make sure only the right people have access to actually write changes to the code. Networking is the same story. How often do you change the base layout? How often do you add a new VPC, an entirely new range? If you're using something like Kubernetes, of course, the story is a little bit different here because you'll be adding private ranges all the time. But if we're talking publicly available routing, that hopefully doesn't change all the time. And even so, make sure those changes are as minimal as possible. So when you start building these patterns and building these modules, make them keep a standard from the outside. The look and feel of your code is something we don't talk about enough. Sure, I mean, we talk about editor theming and making sure we have nice looking icons in the sidebar, but what we should really be talking about is how your code looks like. So think about the visual representation of your code and treat it like the building block you need it to be. That means input variables go into a file called variables.tf. Output variables go into output.tf. We talked about this being boring. If this sounds boring to you, then I'm doing my job right because This is supposed to be boring. This is supposed to be predictable. Your module's main purpose in this case is a compute instance, right? So you're trying to have some compute, maybe 2 data disks like we talked about. All of that goes into main TF. And so you might be thinking, but where do I put my network settings? And do I put both network and compute into the same file, or do I create a network TF and then have it in there? Yeah, you create 2 modules. It is really as simple as that. And to showcase how you use your modules as you build them, if you think about them as building blocks, think about them as Lego pieces. As you stack them, you'll need to have examples. Your compute module can absolutely use a child module for compute instances. That is totally okay. In fact, it's encouraged because it means that a change to one side doesn't necessarily affect the other. But include an examples directory. First of all, it helps you validate your inputs and outputs, which makes your module experience better. And we talked about this before, but your inputs in variable CF are a contract, and they must be treated with respect. They seem like innocent strings, but changing a module's resource identifier will destroy the original resource in Terraform and force you to create a new one. That's disruptive. At the very least, you're recreating something. If you're using a tool like Terraform, CloudFormation is the same, or other tools, and you throw away an S3 bucket, a storage blob, you're also throwing away the contents. Depending on your setup, that might be really frustrating. If you can regenerate the whole contents, cool, throw away the bucket. If not, then today is not going to be a good day. So let's not make things disruptive and be very intentional in what we do. And I've got a little bit of good news here. In Terraform 1.1, this whole process will get a little bit easier, and you'll be able to update moves from resource name 1 to resource name 2 with a moved command. You can currently work around this by using Terraform state move, state MV, but that requires user input and it's less guided. It means it needs to go into your README, into a notes section. You need to make sure a user sees it. Relying on the user is fragile and not necessarily something you can trust. So yeah, having access to config-driven moving of resources to me is much more exciting. Because as your infrastructure evolves, so will your modules. And that might mean updating some names. Now, while we're talking about naming and other things, we should also talk about defaults. Modules should either have very, 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 very sane defaults, or just none. If you're an operations engineer, there's a fair chance that you're a lazy operations engineer because you like to automate things. So don't set defaults. Less typing in the module and more work on the consumer of your module. Sane defaults are not always possible because you might not know a predictable source. But for the module consumer, they have a couple of ways to always predict something. They have a way to predict an experience. So in our case, we want to predict a reliable source, such as a remote repository here that we're using to pull the 1.0 version of the module from the Terraform registry. And of course, just as before, we want to pin this. And then come the input variables. For the website module, we need the Yandex cloud folder ID and a zone. So we're passing these in. And depending on how generic your module is, you might not be able to predict what sane is and what is not. So in the module definition itself, I've omitted those values, which ensures that if you grab this code right now and you run it, once I set the module to public, it will ask you to input folder ID and zone ID. That's good, because I can predict those values for you. So I'm not setting them to something that I know you will have to override. Think of this as fail safe versus fail badly. Luckily, with most infrastructure, you don't have fail deadly, but depending on the industry you're in, you might actually, in that case, to make sure you think about what you're doing. Not trying to sound patronizing here, but this stuff is hard. I've seen it with people using Terraform for 5+ years, that very little thought goes into the architecture of this for very simple things, simple in the sense that they can easily be fixed. And usually down the road, that results in problems. And as before, we talked about validation for variables. Terraform modules have variables, so you can add validation in there. Let's say you know that the website module may only be deployed in zone B and C. You can add the validation in there. We already have the code for that for zone 1A, 1C. Easily copied over, easily maintained here as well. And while you're thinking of sane defaults, also keep secrets in mind. This is hard. So use variable references wherever possible. And then have the consumer of your code or module set them. Either in the execution environment, if you're using something like Jenkins, or GitHub Actions, if you trust GitHub Actions enough to have access to your secrets, or overwrite them in a variable definition file if you're running it locally. And make sure to add that file to your Git ignores. And then, whenever you have inputs or outputs that you can reasonably predict, and we said this before, if you can reasonably predict they contain sensitive data, mark them with a sensitive attribute. This way, they won't be leaked by accident. So, when you spend all that time building this documentation, you're adding descriptions to your outputs, you're adding descriptions to your inputs, you're defining if they're sensitive, you're defining types. You get something pretty nice. You get access to a tool such as Terraform Docs that can parse your input and output values and create documentation from it. We joked about this before, or I mentioned it before, that infrastructure as code was meant to be human readable, was meant to be executable documentation, but we still sometimes need extra context. While Terraform or the Yandex API might understand that with zone, you mean, RU Central 1A, 1C, the human might not know that one of them is for the Vladimir region and the other is for Moscow. So make it easy by generating documentation. I don't want to have to dig in your code to understand what your code does. I want to look at the package on the outside and see what's in there. And usually that means looking at the README. So don't just generate a change log, which is very easy these days. And if you are following the guidelines of having your modules in separate repositories, then hopefully you're generating change logs. But also generate the documentation for it. If the code that you're looking at is the leading source of truth, then your documentation needs to follow. And with a bit of tweaking, you can then have a README file that has all the inputs, that has their name, their value, if there's a default, the type, of course, if something is required, all neatly listed. And this makes your code more useful, more predictable, and because you can see what's inside the box from the outside, it also makes it much more of a joy to use. I'm showing you the rendered inputs here, but if you use Terraform Docs, it will also happily generate the outputs for you. It will show you which provider versions are required, what was the other thing? If there's any module references. There is a lot of information that you can automatically generate without any overhead to you. There's a lot. So we started this journey by talking about an email I received. So I want to quickly go back to that, to the IoT project that we talked about before. The cloud infrastructure we had worked. We were on Azure, and ironically enough, the data center was literally 10 kilometers from us. Those connections were great. Most mobile sensors on the other side, they had severe trouble making connections with their gateways. And we needed to roll out much more hardware to make it work. We went from roughly 20 gateways to 60. So for the final learning for today, make sure your infrastructure works with real network conditions, with real user interactions, not just in a lab environment. If you modularize your code, then spinning up extra environments to test things and carrying out even limited tests is much, much easier. It also means that you can quarantine parts of your infrastructure and debug things in a much easier way. So I want to be clear. The patterns I'm showing you today, the ones that are highlighted, are tried and true patterns. We've been using them for the past half decade. We have guides around this. We build our infrastructure around this. And these enable workflows that don't break as easily. But if you think back to the very first slide, the title of this is Building Infrastructure You Can Mostly Trust. As you saw, we looked at nearly 10 different options to make your infrastructure better, make it harder to break, harder to fail. No single solution on its own is ever going to be perfect, because no single solution provides full coverage for all use cases. Formatting, code validation, version pinning were the basic ones. Then we talked about validating your inputs, over-documenting everything and generating documentation, which is very important. And finally, we talked about modularization with minimalism as a primary concern. Small modules, just the thing you need. And if you need more, you build another module that consumes the module. We made it a little bit better. And if you follow a few of the guidelines here, your infrastructure, your codified infrastructure, will be strong and it will be harder to break it. Now, these are just some of the things that we talked about. We're still not even scratching that deep from the surface. We're not talking about things like key rotation or how to do secrets management properly. We're not talking about networking and dealing with outages. But a lot of the really boring stuff enables the much more interesting stuff. So with that, I have 2 resources for you today. You can find a copy of these slides on SpeakerDeck. And if you head on over to GitHub, pretty sure I made the repository public already. I've got the code that I've used for this talk available for you. I've got a TF-Lint configuration in there, Terraform docs configuration. Everything that I used to generate the README is in there. Feel free to clone it and start your own projects around that. And with that, thank you. My name is Kerim Satirli. You can find me on Twitter and GitHub. My handle is @ksatirli pretty much everywhere. I'm also in the Telegram chat. I'm a senior developer advocate at HashiCorp, where I focus on the infrastructure line of products. That's Terraform, Vagrant, and Packer. It has been an absolute pleasure to talk to my webcam today.
That was great, Kerim. Thank you so much for your presentation. Folks, if you are listening us live, you have a chance to ask a few questions right now before we join in the expert zone. I have a quick question on myself. So you mentioned this about the supporting infrastructure like today, or like doing things that you involve on doing today. And it also actually resonates with my way of thinking. Sometimes you are supporting some of the code that you're writing today, not for someone else, but for you in future. And personally, future me is always grateful when the past me put some of the comments, put some of the documentation, because I know that like when I'm switching context between like doing different things, and again, I'm not actively developing stuff as a kind of like full-time engineer, but I developing a lot of like small things as a developer of the kit. So that's why it is very important for me, develop something that is kind of like a fully fully committed, and after that, someone will be using.
It very much is that. It's, if you take something like AWS, Terraform supports 600 different resources. I know 60 of those well enough to not need the documentation. But then, you're building a demo on something else. Maybe your company uses one cloud for compute, another for storage.
Yep.
This gets hard. This gets really hard because you need to keep all that context in mind. And maybe you just realize that, hey, this resource can't actually be deleted once it's created. Like, it can never be removed anymore. I might remember this today. I might remember it tomorrow. If I'm coming back at this half a year from now, having worked with a different cloud, I might go like, why does this not remove? What is going wrong here, and how should I deal with that? Add those comments in there. Make your documentation just super, super clear.
Great. So I don't see any questions online right now. Hopefully, we will see many of our viewers in Expert Zone. Kerim, thank you so much for your time. I would like to say goodbye to our listeners. And this is the time where you also can say goodbye to our listeners, and we can meet each other in Expert Zone. Bye.
Thank you, and goodbye.